Welcome to Emmelac online tutorial, and before us is this question in heat in physics that says a 500-watt immersion heater is used to heat a liquid of mass 500 through a temperature rise of 50 degrees centigrade in 40 seconds. What is the specific heat capacity of the water? Alright, let us recall that the formula is given as mass, specific heat capacity times change in temperature. Okay, now but in this case here we can see that the heat being generated is from an electric power or from an electrical source, okay, which implies here we have IVT. Okay, the electrical heat is given as this formula, where power is given as IV. Okay, all right, if you have to substitute, so power, which is the IV, power here equals to 500 watts. Okay, then the mass is given as 500 gram, which is the same thing as 0.5 kilogram. Here we are told that the temperature rise is given as 50 degrees centigrade and the time is 40 seconds. Okay, and if you have to implement all this parameter into the given equation, let us start with this. So here our electrical heat is given as power times time, which is 500 times 40. Okay, now this will give us 20. How many zeros? 1 2 3 times 10 raised to power 3, which is the same thing as saying 2 times 10 raised to power 4 joules. Okay, all right, now we've gotten the heat. So here let us now implement this into this. So our H, change in temperature. Okay, we have to find the specific capacity. So here we have 2 times 10 raised to power 4 equals to the mass, which is 0.5, times the specific heat capacity times the rise in temperature, which is this. Okay, in summary we can say this is 2 times 10 raised to power 4 equals this is 5 over 10 times C times 50. This we cancel this. Okay, so we are left with this 25. So here we can say that our C here, making C the solid formula from here, we can now say this is 2 times 10 raised to power 4 over 25. Okay, which is 2. How many zeros? 4. 1 2 3 4 over 25. 5 here, 5 here, we have 4 0 0 0. Okay, then 5 here, 1, then 5 in 40, we have 8, the remaining 2 zeros. Okay, so at the end of the day, what we're going to have here is the specific capacity is 800 joules per kilogram per Kelvin. So this is the final answer to this solution. You can see it's simple, very simple. Alright, if you are new to my channel and you love what I've done, please subscribe to my YouTube channel and ensure you click on the notification button to be notified of every video that I will be uploading on this channel in physics, chemistry and mathematics. Thank you and God bless you.